Welcome to another video of Current Sorcery. In the previous video, I showed you how to calculate the volume of a conical flask. In this video, I'll calculate the level of the liquid when the volume is known. So let's gather up our data. For this demonstration, I will use the conical flask from the previous video. And let's assume that I want to know what the level of the liquid is when the volume is 500 ml. My goal is to mark the level of the liquid on the flask. To solve this, I'm going to use a feature called Design Study. Design studies are means of optimization and evaluation of your designs in Solidworks. This is a powerful tool since it makes Solidworks do all the thinking process and calculation for us. To start a design study, simply right-click on the tabs at the bottom of your viewport and choose Create New Design Study. This new tab contains three minor tabs: Variable View, Table View, and Results View. For this demonstration, I'm going to use the Variable View and the Results View tabs. The Table View is for more discrete variables. Click the Optimization checkbox if it's not selected. My first job is to define the variables of the study. Click the Add Variables option here and choose Add Parameter. The Parameters dialog box opens. Here I can define the variables of my study. I will name my variable Liquid Level. In the Category column, I will define it using a model dimension. I click on the Liquid Level dimension. The Value field automatically inherits the value of the chosen dimension, which is displayed in the Model Dimension field below. I can also add comments if I want to. Once I define the parameters, I click OK. And with that, three fields appear on the right of the defined parameter. These fields include a minimum and a maximum value and a step. In this case, I want any values between 65 to 80 mm and a step of 1 mm. This means that I have 16 possible scenarios and SolidWorks knows that. Constraints are used to specify conditions that the design study must satisfy. In this case, constraints are not necessary. To optimize my geometry, I need to specify my objectives correctly. To define goals, click on the Add Goals drop-down. Here, I can either create a new sensor or use an already created one. I will use the sensor I created in the previous video. Once I do so, another field appears. This field defines my goal. I can minimize, maximize, or make a close approach to a value. I will choose the close to option and define a value of 500 ml. Once I define parameters and goals, I click Run. SolidWorks transfers me to the Results View tab, where all 16 scenarios are presented in a tabular form. There are also three columns which show the current, the initial, and the optimal values that were calculated in the study. The optimal column shows in brackets the number of the scenario whose values are closest to my goal. So the closest value to 500 ml is when the liquid level is 71 mm, and it's 501.02. I can click any scenario I want, but I will go with the optimal one. This may seem a good result, but we can do better. Let's try a more accurate approach. I will return to the variable view, and with the knowledge I acquired from the previous design study, I will create a finer analysis. This time in the parameters field, I will define a minimum value of 70.5 mm and a maximum of 70.7 mm. I will define a step of 0.01 mm. I do not need to change anything else from the study, so I hit the Run button once again. So according to the results we got from the design study, when the level of the liquid is 70.65 mm, the volume equals 500 ml exactly. At this point, I could run multiple studies and get more values. I have already run the design study for 400, 300 and 200 ml, and I have created a sketch with the levels of each different volume. To add a finishing touch, I will use the split line command to project the sketch directly on the face of the flask. And that was a short demonstration of the Design Study capabilities. We saw only a little of what Design Study has to offer. Regardless, it's a great tool that can help you save time and work efficiently. Don't forget to like this video and subscribe to my channel for more content. Until next time, thanks for watching.